Hello everyone, welcome back to Piece of Physics. In this particular video, we are going to see the new topic of kinematics, which is speed. Okay, generally we can say that speed is a motion with the time, right? So what is speed? Speed is basically distance upon time. Okay, so whenever distance changes with the time, in that case, we can say that this particular quantity is also known as speed. Okay, so here we can easily define what is speed. So distance traveled in unit time is known as speed. Okay, the symbol of the speed is basically taken as nu, which is distance d divided by time t. Okay, so here we can say that distance is unit of distance is basically meter, and the unit of time is basically second. Okay, so the meter per second is the unit of the speed. Okay, so also we can say that the dimensions of this particular quantity will be m0 l1 t minus 1. Okay, so the dimensions is m0 l1 t minus 1. Here distance is the scalar quantity and time is also a scalar quantity. That's why speed will be also become a scalar quantity. Okay, so the speed has to be taken as a scalar quantity, right? Also, if object is moving, then distance will always increases. In that case, speed will become positive. And if object is not moving, in that case distance will not change, and such kind of case the speed will be 0. Okay, so the one unit we commonly use in SI unit system is the meter per second. The another unit which we use in real life is kilometer per hour. Okay, so basically 1 kilometer per hour can be written as 1 kilometer is 1000 meter and 1 hour is 3600 second, right? So here I can take it as 10 by 36 meter per second. Okay, so it can be written as 5 by 18 meter per second. Okay, so 1 kilometer per hour equals to, I can write it as 5 upon 18 meter per second. And also I can write 1 meter per second equals to 18 upon 5 kilometer per hour. Okay, so basically if you are given the speed as 54 kilometer per hour, okay, so it will be written as 54 into 5 by 18. Okay, so I can cancel 54 with the 18 at 3, so it will be 15 meter per second. Okay, so 54 kilometer per hour is 15 meter per second, right? Also, if I want to convert 20 meter per second to the kilometer per hour, so it can be written as 20 to 18 upon 5. So here it will be 4. So 18 fours are 72 kilometer per hour. Okay, so that's how we can convert kilometer per hour to meter per second and meter per second to the kilometer per hour. Okay, so that's all for the basic concept of the speed. Now let us move to the average speed. So what is average speed? If any object is traveling from one point A to another point B like this, okay, so in this case, okay, now object has different speed at different point, right? So the we can have total distance between A and B, and we can also find the total time from A to B. Okay, in such case average speed will be equals to total distance traveled divided by total time taken. Okay, so total distance traveled divided by total time taken is known as average speed. Now the symbol of average speed can be taken as v average, like this, two triangular brackets like here, v bar, v mean, v average. Okay, so these are different symbols of average speed which can be taken in notation. Okay, now let us see what is instantaneous speed. Okay, so basically we just looked into the how average speed is working, right? So basically average speed is total distance upon total time taken, right? So instantaneous speed is basically taken as the speed at any particular moment is known as instantaneous speed. Okay, so basically I can take average speed as delta x by delta t, where delta x the distance between 2 points and delta t is the total time between 2 points. Okay, now what is the instantaneous speed? Instantaneous speed is taken as speed at any particular time. Okay, that particular speed is known as instantaneous speed. Basically v instantaneous is taken as limit delta t tends to 0. It means I have made the time interval to be extremely nearly equal to 0. Okay, but it is not 0, so I can take it as delta x by delta t. In such cases delta will be converted into dx by dt. Basically this is the time derivative of the distance. Okay, so basically time derivative of distance is known as instantaneous speed. Okay, so instantaneous speed can be written as dx by dt. That's what we will remember in short. Okay, so now let us solve few problems based on the instantaneous speed and average speed, so we can have some idea how to deal with such kind of problems. So we have one problem here. The distance traveled by a particle in time t is given by d equals to 2.5 meter per second square t square. Find the average speed of the particle during the time 0 to 5 second and the instantaneous speed at t equals to 5 seconds. So we are given the equation of distance as 2.5 t square. Now we have to find average speed between 0 to 5 seconds, right? So the average speed is basically delta x by delta t, as we know. So here we will have x at 5 minus x at 0 by 5 minus 0. Okay, so x at 5 is I can find d at 5 second will be 2.5 into 25. The 2.5 into 25 is basically 62.5 meter, and distance at 0 second will be 0 meter. So basically this is 62.5 minus 0 divided by 5. So the average speed will be equal to 12.5 meter per second. The second part is the instantaneous speed at t equals to 5 seconds. So the distance is taken as 2.5 t square. The speed will be equal to, here I can write it as x as well. So instantaneous speed is basically dx by dt. Dx by dt is basically 5.0 t. So v at 5 second is 5 into 5, 25 meter per second. So the speed, instantaneous speed at the 5th second is basically 25 meter per second. But here you can see that the average speed between 0 to 5 second is taken as 12.5 meter per second. So that's how pretty average speed and instantaneous can be distinguished. Okay, so both are the different concepts. The average speed is taken for the entire journey, and instantaneous speed is the speed of the object at any particular time, right? So that's all for this particular problem. Now let us move to the another problem. Okay, so the problem is like a man walks at a speed of 6 km per hour for 1 km and 8 km per hour for the next 1 km. What is his average speed for the walk of 2 km? Okay, this is 1 km. This is 1 km. Okay, and the speed here is 6 km per hour. The speed here is 8 km per hour. Okay, so the basically speed equals to, I can write distance upon time, so and time will be distance upon speed. Okay, so here the time t1 is taken as 1 by 6 r, and here time is t2 is taken as 1 by 8 r. Okay, so the average speed is basically taken as total distance divided by total time. Okay, total distance is basically 1 plus 1 km. Total time is taken as 1 by 6, 1 by 8. Okay, so this is 2 km. Okay, so here 24 is the LCM, so I can put 4 plus 3 divided by 4r. Okay, so this is 2 into 24 kilometer and divided by 7r. This is V average. Okay, so 2 into 24 is 48 by 7 kilometer per hour. Okay, so here the average speed of this particular walk is taken as 48 by 7 kilometer per hour. So that's how we can deal with such kind of problems in which we can find the average speed. Okay, so that's all for this particular topic of speed, average speed, and instantaneous speed. Stay connected to the channel for further videos of kinematics. Thank you.